Alright guys, so now we're back with part 2 of the classifying triangles notes. We're going to work on more mathy type problems. We're going to work on the classifying triangles in the coordinate plane. Then we're going to move on to solving for sides with algebra, which is probably going to be the most, well actually both of these types of problems are very huge EOC type problems, okay? Especially this distance formula one. The coordinate plane, you're going to be sick of it by the time you're done with this class, and especially the distance formula. So might as well get practice using it now and get good at it, while we still got time. All right. So these problems, don't let these problems scare you, okay? Upon first look, they give you some coordinates and it says, classify the triangle based on its sides. And, okay, well, what do I need to know about sides of a triangle to classify? I need to know how long they are. Or I need to at least know how they relate to one another so that I can make some conclusion. Is it isosceles? Is it scalene? Is it equilateral, right? So I'm going to use the distance formula here. Let me make a note of this distance formula. And you guys have actually done a really, really great job with this. A lot better than years past. So let's just recap and then we'll move on. This term right here, this x1 minus x2, all that is the distance from one x coordinate to the other, right? So I don't have to sit here and actually subtract these x coordinates and get all confused with my signs. What I could do is just say, like, for example, if I had the point negative 3, 7, and 9, 6. If I want the distance in the x coordinates, I just have to ask, okay, well, how far away is negative 3 from 9? Well, negative 3 to 0 is 3 units. 0 to 9 is 9 units. 9 plus 3, that's 12 units, right? So I could just plug that in, 12 squared, boom. It doesn't matter if it's negative or positive because once you square something, it's always going to be positive regardless. All right. Same thing with the y's. I'm not going to spend time, going over that. But, the distance in these y's from 7 to 6, they're just 1 unit apart. So you would just square that and then you're good to go. All right. So find the measures of these sides. So here's what I need. I need side JK, side KL, and side JL, right? There's 3 sides on a triangle. There's 3 points. You got to hook up all, the points twice. So here we go. All right, so side JK, what's the difference in the x's there? Well, between negative 7 and negative 9, that's a 2 unit separation. What's the distance in their y's from negative 7 to 1? Well, negative 7 to 0 is 7 units away. 0 to 1, that's 1 unit away, so that's 8 units apart. So I got 4 plus 64, that is 68. For these problems, don't even worry about reducing this, okay? We're not even going to go there because I don't care what this is reduced as a decimal, as a simplified radical. I don't really care, all right? All I'm trying to do is see how these sides relate to one another. Let's look at KL, okay? What's the difference in the x's? Well, I got negative 9 to negative 1. How far are they separated from each other? 8 units. How far are the y's separated from each other? 1 and negative 1. That's a 2 unit separation. 64 plus 4, 68. There we go. So we know this is at least isosceles. We just need to try JL, go from there, see how that's going to look. From negative 7 to negative 1, that is an 8 unit separation. No, it's not. I goofed. What is it? From negative 7 to negative 1, that's a 6 unit separation. Okay? And then same thing, negative 7 to negative 1 in the y's, that is also 6 units of separation. 36 plus 36, that's going to give me 72. Only two of the sides look alike, so we know this is an isosceles. There we go. All right. Let's take a look at, let's just do 23 and we'll move on. All right. Also, if I'm going too fast for you, which I might be because I'm trying to beat this software and have it not crash on me again, you can always pause the videos. And I'm going to try to upload these to YouTube so you can also slow it down if need be. Okay? All right. So, three sides of a triangle. Let's tackle this one. JK, the differences in the x's. From 1 to 3, that's 2 units. From negative 13 to 3, that is 16 units separated between them. I got 4 plus 16 squared. We might have to go to the calculator for that. That's 256. So this is the square root of 260. All right. Let's look at KL. How far apart are the x's in KL? So how far apart are 3 and 10? They're 7 units apart. How far away is 3 and negative 6 from each other? That's 9 units apart. So I got 49 plus 81 square root of 130. All right, now JL, from J to L, 1 to 10, that's a 9 unit separation. Negative 13 to negative 6, that is a 7 unit separation. So I got 81 plus 49. Hey, that looks like KL. So I know this is an isosceles triangle. All right. That's how you're going to tackle these problems. Work on your distance formula. Get it done. Okay. Let's look at some of these algebra ones. Solving with algebra. Okay. The key thing to know here is when you read the problem, pick out what type of triangle it is. So like for number 1, it says ABC is equilateral. That means all these sides are going to be congruent. Okay. We can look at like number 4. It says triangle DEF is isosceles, and then it tells us what two sides are congruent. So then make those marks as well. So you know that you could only set side DE and EF equal to each other to solve that. All right. So let's look at number 1. It says if triangle ABC is an equilateral triangle, solve for both x and y. As I inspect the figure that they give me, I see that I already know one of the sides, AB, is 49 meters long. And I have the side BC is 3x plus 1. All of these sides are equal to each other. So I could do that. Then I can also do 18y minus 41, set that equal to 49, and solve from there. Okay? I'm going to do some fast math here. By this point in this class, you got to be real quick with your algebra. All right? Can't be making those silly mistakes. All right, got 18y equals 49 plus 41. That's 90. Divide that by 18. You get 5. Did I answer the question, solve for both x and y? I absolutely did. If you look at number 2, it says if triangle RST is an equilateral triangle, find x in the measure of each side. Well, that's easy enough. If it's equilateral, all the sides are going to be the same. So once you know one side, you can figure out the others just because they're all the same. But how can I solve for x? You should always ask yourself, does it matter what sides I set equal to each other? And in a problem like this, if it's equilateral, it doesn't matter, right? You can set any two equal to each other, and go from there. So I'm just going to set 12x minus 22 equal to 10x minus 6. Go from there. So subtract 10x from both sides, you get 2x. Add 22 to negative 6, you get 16. Boom, x equals 8. Then I could just plug this into any of these sides that I want to get the measure of each side. Let me do ST. So ST is equal to 10 times x, which we know is 8, minus 6. That's 80 minus 6. ST is equal to 74. Which must mean that the other sides are equal to 74 as well. Now, if you want to check if you're right, what could you do? Well, what you could do is plug in 8 to the other sides and see if they all get 74. If they do, you know you've done it correctly. And if they don't, then you probably need to go back and look at your algebra and make sure you didn't make a silly mistake. All right? Let's look at number 4, because this one is specific with what side you set equal to each other. This is isosceles, okay? In an isosceles triangle, you can only set the sides that are congruent to each other equal to each other, right? So don't get tripped up. I can only set 8x minus 13 equal to the 5x plus 17. It's the only expression I can write from this figure, okay? Don't make a fatal error and set it anything equal to x plus 21, all right? So subtract 5x from both sides, you get 3x. Add 13, you get 30. X equals 10. Find x. I'm only halfway done because now I need to find the other sides. Well, let's find DE. DE is going to be 8 times 10 minus 13. So that's 80 minus 13. That gets me 67. I also know that EF is going to be 67 because they're congruent to one another. And DF, I actually have to solve. It's going to be 31. All right? DF is going to be 31 units. The other two sides are 67. All right? All right. Let's finish this up. 6 through 10. What do we notice? What's the difference between 1 through 5 and 6 through 10? Well, 1 through 5, did they give you figures? Yes, they did. 6 through 10, did they give you figures? No, they didn't. Number 1 rule of geometry. No figure. You need to draw one. Geometry is a very visual class. Spoiler alert, okay? So make sure you're drawing when it doesn't give you figures. So for example, number 6, if triangle PQR is an equilateral triangle, stop right there. Draw a triangle. Label it PQR. How can I show someone that this is equilateral? Put little tick marks on all the sides. Then when it gives you the side lengths, write them in. If you don't do this, you're going to set yourself up for failure, all right? So just do it. I know it's tedious, and I know some of you think you're above this. That's okay, but you're more likely to get it right if you set up the figure, see what you're doing, all right? All right, find x. Find the measure of each side. Does it matter what side we set equal to something else? No, it doesn't. Okay? So I'm just going to choose 18x plus 1 equal to 15x plus 10. Subtract 15x on both sides, I get 3x. Subtract 1 on both sides, I get 9. X equals 3. Set it equal to one side. Let's just do PR. Okay? So PR is 15 times 3 plus 10. It's going to be 45 plus 10. That's equal to 55. All right? So PR is 55. We're going to know the other sides are also 55. All right. Now, number 7, real ugly. And the reason why number 7 is real ugly is because it doesn't give us straight up expressions. It makes us work for it, okay? And I know you guys can do this, okay? You just got to be real careful with your reading. So, for example, it says if triangle STU is an equilateral triangle, boom, stop, draw. Equilateral, bam. Let's decode this. ST is 1 less than twice x. All right, twice x. That means 2 times x. 1 less than that, what does less than tell you? Add or subtract? Subtract. You just got to be careful with where it goes. If it's 1 less than twice x, that's 2x minus 1. Okay? Just like if someone said $25 less than $100, is that going to be 100 minus 25 or 25 minus 100? It's going to be 100 minus 25, $75. All right? So I decoded the other ones for you. SU is 37 less than 5 times x. That's 5x minus 37. TU is 11 more than x. More than signifies addition. So we add x and 11. All right. This is equilateral. I'm going to set any two sides equal to each other. Let me get a different color up in here. So let's just set x plus 11 equal to 2x minus 1. Subtract x on both sides. I'm going to get x here. If I add that negative 1 to the other side, it'll be 12. So x is equal to 12. Then I can plug that 12 back into any one of them. Let me do ST. That's 2 times 12 minus 1. 2 times 12 is 24. 24 minus 1. ST is equal to 23. All right. If ST is equal to 23, and this is an equilateral triangle, then SU is also 23, and TU is also 23. All right. Let's finalize this with number 10 because it is one of the more advanced ones. It says triangle GHI is an isosceles triangle with GI congruent to HI. Let's just draw this out. Doesn't matter which way you label it, as long as you label it correctly. GI is congruent to HI. Okay? And then we decode. GH, 3 more than X. Remember, more than is addition. HI, 17 less than 4X. Okay? 4 times X, rather. All right? So which two of these can we set equal to each other? We can set GI equal to HI, solve, find the measure of each side. Let's get it done. Okay? Subtract 4x on both sides, you get 2x. Add 45 to both sides. You get 45 minus 17, you get 28. X is equal to 14. Let's plug it back in and solve away. GH is 14 plus 3. Therefore, GH is equal to 17. HI is going to be 4 times 14 minus 17. Got some calculator work here. 56 minus 17. is 39. So if HI is 39, then we also know GI is 39. All right? What I want you to get in the habit of doing, because when we get into class on Monday, you're going to get this homework assignment. It's right here. All of these problems look exactly like the problems we just did. All right? So make sure that you are working homework out with the notes right in front of you so you can draw connections between what we did in the notes and what we're going to do on the homework. All right? Like I said, it's up to you to get this information. You need to take ownership of your learning. If you're not understanding something when I'm saying it in the video, you should pause it, you should slow it down, and then if you still don't get it, ask me when we're one-on-one with each other in class. All right? Take care.